I apologize for the technical difficulties yesterday, but those things happen. And just as a heads up for everyone, tomorrow I have a meeting that's going to run over 4 o'clock. And I suspect, given what I'm seeing timing wise, that meeting is going to probably run up until 5 o'clock. And so what I'm going to do tomorrow is I'm going to just go ahead and turn you loose on doing some laboratories. I will post the final lab for the semester, which is your project lab. And I will do a little bit of a voiceover so that you have that. Your final lab is going to be doing a pinhole camera projector and then doing a collection of photographs dealing with light. I have several that I have done where you're looking at reflection, refraction, you're looking at what forms a rainbow. Had a beautiful rainbow last night as I was driving back from Enid, only to be hailed on for 20 minutes. So that tells you what yesterday was like for me. But being able to see that rainbow was really nice. It was an actual big, broad rainbow, which was pretty cool. So those things are there. So you'll have that. And I would encourage you to go ahead and take some time to look at that laboratory and to look at some of the things that I've added. And I've added several things today. So I kind of want to show you what I've added. So I'm going to share my screen and we will talk through a couple of the things that have been added. All right, there we go. And it looks like the shared screen is available. In the laboratories, I had a couple of questions, and so I wanted to go over those questions. If you just went in to look for how to upload your lab for the first two labs, and you went in through the calendar, you may not have been able to tell which one was which. So because somebody pointed that out to me, I have put in this folder here. They submit your PDF for your one-page laboratory memorandum for lab 1. So that's really identified so that you know that that's exactly what I'm looking for lab 1. And then for your simple harmonic motion with a pendulum, I have gone ahead and submit your PDF of your laboratory memorandum for lab 2. So that should make it a little clearer as to which lab goes where. So hopefully that will get spots going. I appreciate everybody. I've kind of gone in and have looked at some of the videos that you guys have put in. So that's very helpful. And I'm definitely looking at that. I haven't scored anything yet and I haven't responded to those, but I am pretty impressed that you guys have gone out and have already done some cool simple harmonic motion. One of the things that I have added is in the simple harmonic motion lab, I did a video today deriving the relationship between period and link for that simple harmonic motion lab. I have gone in and I've responded to those of you who've already posted in the simple pendulum discussion board. And I've put that in as a response to the posts. And I've also put it right here for you all to be able to find it. Hopefully that will make a little bit more sense, and I built that one up a little bit. That was one of the topics I was going to cover last night. And so I've actually built a one-page slide, did a voiceover, and hopefully that will get you guys pretty well off on that one. Another thing that I did, because we didn't have our opportunity to meet yesterday, is in the lecture videos, and I have now added lecture notes. So I broke up chapter 13 into 2 parts. I broke it up into the simple harmonic motion part, and I broke it up into the waves part, because we're doing both. Hopefully that will allow for you to look at the key points that I want you to see in simple harmonic motion. Tonight, we're going to do a Hooke's Law problem so that you can remember how to do a Hooke's Law problem and talk through that. We're going to look at the equations for position, velocity, and acceleration in the simple harmonic motion. So we're going to be talking a little bit about that. We're also going to be looking and defining waves tonight. So that's something that we're all going to do a little bit. And I will parcel that up. I've gotten pretty good at doing editing on the fly for my videos. So, I will stop, take a breather, and then we'll do those pieces. So that's something else that's there. You should have, there's that same video on the simple pendulum derivation for the relationship to period to length. So that's in that set of videos as well. So that was added today. And I added an assignment today. So I wanted to kind of highlight this assignment. It is a video review. I created a video today using AI. I was playing with AI and I tested it out. And so when you open this, what you're going to see and you'll click on it's the assignment content. There is a video in the assignment. As you can see, it's less than a minute. It's only a minute long. But what I was trying to do was get some images for folks to understand how a simple pendulum, the bouncing spring, and a bead traveling around in a hoop all represent simple harmonic motion. So I put in a prompt and I did it. And this is the video that came up. So you guys know that it's AI. I'm asking you to answer 5 questions, or maybe I guess it's only 4 questions. So it's worth 8 points. I'm asking you to review the video. Did it help? Did it hurt? So it's really a do it and you get the points for this homework assignment. So I'm asking truly for your honest opinion. Could you tell it was AI? But one of the things to note, you can see that some of these are watermarked. And watermarking doesn't necessarily tell you that it's AI or not AI. I've had watermarked images for other things that I've done. And so that's not going to be something that would give you a clue that it was AI. So I'm really trying to find out, did it help? Did it not help? Just to see that. And it's a do it and you get the 8 points. So that's that homework assignment that's in there. And that one is going to be due the 30th of June. So you have several things that are due on Sunday. So that will help us out there. Finally, I think everything else, it looked like I haven't double checked yet to make sure everybody's gotten into WebAssign, but I've had several people contact me about WebAssign homework. So I know that a lot of you are already in there. I just haven't had a chance to do a one-to-one check to make sure that everybody's gotten in. So I appreciate that. It looks like you guys dove into the homework and got everything going. I sent out an announcement earlier today because a lot of you were having trouble with part C of a couple of the problems. And it was basically, you had a number, you had the sign of a number times time. And when you calculated your number, it wasn't giving you the right answer. Well, 9 times out of 10, if that is the case, think about going back to Physics 1 when we started with angular frequency and we started with our circular motion. We had to change our calculators from degrees to radians. So I'm almost dead positive that most of your problems or most of the issues that folks were having is that they weren't doing the calculation in radians, and that's going to screw up your sine or your cosine. So when you're working with these kinds of problems, you really, really want to be thinking about angular frequency and you really want to watch your units and you want to make sure that you're in radians. And the reason we use radians is because that's a unitless number. So that allows us to do some other multiplication and other things. So hopefully that will help with that problem. So any question about what's immediately due, where something is located, or what I'm expecting, and before we jump into kind of lecture material. And you feel free to use the chat.